Student friends, once again we are continuing with topic number first of paper 16, that is optical fiber communication. Students, yesterday we have studied one of the element in the block diagram, and that is light source that is used in a transmitter to launch the optical energy into the fiber, so that due to total internal reflection, the injected light radiation will travel from one end towards the another end. We studied LED as a light source. In short, we have studied its constructions, its properties, which are suitable to launch the maximum optical power into the optical fiber. We studied how optical fiber cable is connected into the LED with the help of surface edge LED and also the edge emitting LED. So both the type of LEDs we have covered diagrammatically. After that, we are well aware that these LEDs are driven by means of a driver circuitry, so that it will start emitting the light radiations which are expected to be launched into the optical fiber. So that's fine. In the next step of the block diagram, whose details we are going to cover today, and that is the meaning of optical fiber, what exactly it is, how it is constructed, what are its types. All those aspects we are covering under the title known as fiber optic cable or optical fiber cable. Dear students, already we have defined the optical fiber. Once again, I am going to repeat the definition, and that is an optical fiber cable is a cylindrical waveguide made up of dielectric material which is going to be operating with the optical frequency by confining the electromagnetic energy in the form of light within the surface and guides in parallel to the axis or along the axis. So this is the basic definition of the waveguide, or optical fiber. Once again I will repeat it. Optical fiber is a cylindrical waveguide made up of the dielectric material which operates with the optical frequencies by confining the optical radiations as electromagnetic radiations in the form of a light and guides along the axis of the optical fiber or parallel to the axis of the optical fiber. Such a cylindrical waveguide, we can call it as it is the optical fiber. Obviously, it is a very thin, its diameter is very less. It is a hair-like structure. The structure of optical fiber is going to depend upon information carrying capacity, means how much amount of information is to be carried away, and also the environmental perturbation, means in which environment does the optical fiber we are going to use, meaning thereby whether optical fiber is hanging in air, or it is buried in the duct, or it is to be used in a sea underwater. That decides the structure of optical fiber cable, and also what type of information is to be carried away, whether it is a digital data, whether it is only voice signal, whether it is audio signal, whether it is video signal, whether it is audio as well as video signal. This will decide the structure of optical fiber. Accordingly, we can say, if you consider a single cylindrical optical fiber as a waveguide, that is made up of dielectric material of certain radius, say A, we are going to observe these in the diagram which we are going to discuss after this slide. If the radius of that particular optical fiber having a cylindrical shape is A and refractive index is say N1, the cylinder is known as a core. Core means inner part of the optical fiber. We already studied, when we have studied the principle of optical fiber, that is refractive index of core is more than that of refractive index of the cladding. And because of this only, the total internal reflection it is possible. Core means the dielectric material which is present within center part of the optical fiber in the form of cylindrical form. That possesses the radius A and say refractive index N1. This core of the fiber is surrounded by the dielectric cladding with another material having the refractive index An2, and the refractive index of the N2 is less than that of refractive index of N1. Means the refractive index of cladding is less than refractive index of core. Cladding is not necessary for propagation, but it reduces the scattering losses due to dielectric discontinuities at the surface. That gives mechanical strength to the fiber. It protects the core against the contamination at its contact. One thing it is clear, it consists of core and cladding. Core is the center part, it is surrounded by means of a cladding, both having a different refractive indices. Under the consideration that a refractive index of cladding is less than that of a refractive index of core, cladding is necessarily used to protect the core, to provide the mechanical strength to the fiber, and it is also used to protect the core against the contamination at its contacts. Contamination means, in Marathi we can call it as a samsarga. Against that particular contamination it is going to be gets protected, and that is the role of cladding, which is coated around the core. Within the core, light radiation travel. In low and medium loss fiber, core material is glass, means core is made up of the glass, which is surrounded by either glass or plastic as the cladding. Means material used to fabricate the optical fiber is either glass or plastic. If the loss is less or it is medium, then core is made up of the glass, it is surrounded by the cladding which is made up of the plastic or even with glass. But if losses are more, core is made up of the plastic and cladding is also made up of the plastic. This entire fiber containing core and cladding is encapsulated in an elastic aberration having the high resistant plastic material. Means the combination of core and cladding is inserted within the elastic aberration. Over that the elastic coating will be put, which is made up of the high resistance plastic material. Why this? This is because to introduce the mechanical strength to the fiber and isolate or buffer fiber from the geometrical irregularities, distortion or roughness of adjacent surface. These may otherwise arises scattering losses. Means to reduce the losses, to provide the higher mechanical strength, the combination of core and cladding is encapsulated in highly resistant plastic material. So this is how the optical fiber is constructed, or this is what we can call it as the structure of optical fiber, which is represented in this particular figure. Dear students, these are the constraints which we have just studied so as to call it as entirely the optical fiber. Look at here. This is the core. It is a cylindrical waveguide. Within this core, the light radiations will travel. To this end, LED as a light source with geometrical characters which are well matched is connected, that launches the maximum optical power within this particular core. Core has a radius A, which we already represented. It has a refractive index is N1. This core is surrounded by this red colored cladding. This is core, whereas this red colored is cladding. It is a silica. Silica is a material that is used to construct glass or even plastic. So that's why its contents are going to be gets mentioned. So this core is surrounded by the cladding. Its refractive index is N2. N2 is less than that of N1. This entire aspect is encapsulated in a different coatings. Different coatings are used just to provide the maximum strength to fight against the environmental mechanical perturbations in the atmosphere. Maybe it is followed by means of a silicone coating again, and these are the different buffer jackets. This entire structure is encapsulated in the high resistance plastic material. Purpose is to strengthen the fiber. Friends, you studied that optical fiber is buried in the ground. If suppose some heavily loaded vehicle travels over that, it may go into damage. So to give protection against that, all these different layers are going to be gets arranged on the optical fiber. Finally, a black polyurethane outer jacket is going to be put, which is a very hard, that protects that particular fiber. Dear students, please try to remember this entirely we can call it as optical fiber cable. But actually light is traveling within the core only. But remember, core and cladding plays a very vital role to produce the total internal reflection for the light radiation within the core. The rest of the aspects are used to protect the small hair-like fiber to give more strength to that particular fiber. So this is what we can call it as the construction of the optical fiber. Now we are going to see the types of the fibers, optical fiber cables. Basically, depends upon material compositions which are used. Optical fibers are divided into two types. One is a step index fiber and second one is graded index fiber. In step index fiber, refractive index of core is a uniform. What is that? It is a uniform. Means, so this is what we can call it as the step index type of the fiber, where the refractive index is uniform. There is no change in refractive index from one end towards the other end of the fiber, and undergo abrupt change in the cladding boundaries. But in graded index fiber, the refractive index varies as a fraction of radial distance from the center of the fiber. That is the difference between step index fiber and gradient index fiber. In step index fiber, a refractive index remains same, but it abruptly changes at the boundary. But in gradient index fiber, a refractive index varies as a function of radial distance. These are again divided into two types. One is monomode fiber and second one is multimode fiber. Monomode means maybe it is a step index or maybe it is a gradient index type of the optical fiber. If the light travels within only one mode, then it is called as a monomode fiber. And if the light radiation travels in the multiple modes, then it is called as multiple mode type of the fiber. Thus we can say basically there are two types. One is a step index fiber, the second one is a gradient index fiber. In step index fiber, the refractive index will remain uniform throughout the fiber but abruptly changes at the boundary. In gradient index fiber, the refractive index continuously changes from one end towards the another end. Monomode fiber sustains only one mode of propagation, whereas a multimode sustains several hundred modes of propagation. Multimode fiber has advantage of large core radius and makes easier to launch the optical power into the fiber and facilitates connecting together similar fiber. Means many such fibers are going to be gets connected with each other. This is the facility which is going to be provided with the multimode fiber. LED is a suitable light source for both of them, that is multimode fiber, but single mode optical fiber uses the laser diode. Multimode fiber suffers with intermodal dispersion. Intermodal dispersion is a result of many modes of light pulses in the fiber and end at slightly different times. Due to as being multi-modes are there is a phase difference, there is a path difference. At the cost of that, there is an internodal dispersion is going to be gets resulted in the multimode fibers. This causes pulse to spread along the fiber and known as intermodular dispersion. It can be reduced by gradient index profile in the fiber for the purpose of establishment. In short, you can remember there are two types of the optical fiber. One is a step index, second one is a gradient index. Step index and gradient index both are divided into again two types. One is a monomode fiber and second one is a multimode fiber. So these are the types of the optical fibers which are used in practice to carry the light radiations from one end towards the another end. Dear students, this is a diagram that represents the types of optical fiber. Look at here. This is the core representing the refractive index N2, whereas this one is the dimension of core representing the refractive index N1. So this is the diameter 2A of the core, means radius is A. So this is the cladding, whereas this one is the core. The light radiation travels in a state. This is the monomode type of fiber. It has entire diameter of 125 micrometer cladding, whereas core diameter is 8 to 12 micrometer. So within 8 to 12 micrometer diameter, the light radiation travels within only one mode. That is the monomode. Maybe it is a step index or maybe it is a multimode, gradient index type of the fiber. Below that represents, again core has a refractive index of N1 and the cladding has a refractive index N2. But here the diameter of the core is much more than that of diameter of step index fiber. As the wing diameter is increased, LED can be suitably used as a light source. For this, laser diode is going to be used as a light source. Here, diameter of cladding is 125 to 400 micrometer, whereas the diameter of core is 50 to 200 micrometer. Within that, when light radiation inject, they will travel and touches to the boundary between this is the core, and whereas this is cladding, and this dotted line represents the boundary. When it touches to the boundary, it will internally reflect. It touches to the lower boundary, again internally reflect. Like that, it will propagate from one end towards the another end. This is again for step index fiber, meaning thereby a refractive index remains uniform. So this is the multimode fiber. With graded index fiber, it is represented. Difference is that here also both possess the different refractive indexes. The diameter of cladding is again 125 to 140 micrometer, whereas the diameter of core is 50 to 100 micrometer. But here a refractive index varies within the optical fiber from one end towards the another end. And hence, again due to the total internal reflection, the signal will be carried away. But these multimode fiber may going to produce intermodular dispersion. So these are the dimensions which are associated for the different types of the fibers which are being used practically to carry the light radiations from transmitter towards the receiver. So that's what we can call it as the types of optical fibers. Dear students, that's all about meaning of optical fiber, its definition, its construction, and also the types, their dimensional characteristics as far as the monomode, multimode, step index, graded index type of the optical fibers. Today we will stop, rest we'll see in the next period.